Okay. All right. So we're talking about the doubling coin. Okay. So suppose that you have a coin whose value doubles every day. That is on the day you get it, day 0, the value is 1. On day 2, the value is 2. On day 3, the value is 4. On day, you get what I'm saying?
Yes.
Every day the value is going to double. So it asks, how many days will it take you to become a millionaire? Okay. That's what we're going to work through. How many days is it going to take us to become millionaires with our magic coin? And it's not a divide by 2. All right. So because it's growing rapidly, this is a sign that we are making an exponential, an exponent. Okay. We know that we're dealing with an exponential. Okay. Because of it's an exponential, we have the format of f of x equals a times b to the x, correct? A is our what value? Initial. What is the initial value of my coin? 1. Okay. Your b is your growth rate. How is my coin growing? Doubling. So then my b is what? 2. So therefore, my function would be f of x equals 2 to the x. 1 times 2 to the x. Agree? Yes? Are we still together? Cool. All right, we're going to make a table and a graph to support this. So my table, my x values, and my y values. Day 0, I'm worth how much? 1. Day 1, 2. We're only going to go up to 5. Is that cool with y'all? We're in 1, 2, 3, 4, and 5. So my values are 1, 2, 4, 8, 16, and 32. Okay. To fit this in, we're going to count by 2s on our y-axis. And we're going to count by 1s. Uh-oh. My line didn't make. Let's try that again. I could be a cheater and try to use the line tool, but I'm trying to be, authentic. So pretend that these are the straightest lines you've ever seen.
Absolutely.
Yep.
Wow.
Even that.
Beautiful.
Even that. George, you were determined to use that word, aren't you? Okay. 1, 2, 3, 4, and 5. And I'm going to let each one of these be 2. Should that get me there? Yeah. We'll count by 2s. All the way up. All right. So on day 0, at day 0, I am at 1, right? Right there. Smack dab at 1. Agreed? On day 1, I'm where? 2. Day 2, I'm at 4.
Wait, I have a question. Why couldn't we have just used the edges?
You could have. I just didn't want to.
Oh.
Seriously? No, the edges don't-
You didn't have to copy my graph.
Oh, you did this. so
2,
that you
4,
wasn't
6,
copying.
8.
What?
2, 4, 6, 8, 10, 12, 14, 16. Boom. 16, 18, 20, 2, 4, 6, 8, 30, 32. Go, 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 go. Oh, I did make it. Let's try it again, guys. I'm going to touch that point. I'm determined. Oh, close enough. All right. There's my beautiful graph.
Wait,
Yeah. Does your graph look as gorgeous as mine?
Yeah.
wait, so are you fine by, means on that stuff on the left, on the y-axis?
Yeah, I said that.
Oh.
Then I'm going to count by 2s on the y-axis in order to fit all my points. Thanks for listening. Okay, so it says, how could we use this function to model and decide when to choose a doubling coin over the single payment of 1 million? Okay, so when I'm looking for this, is 1 million my x value or my y value? It's my y. It's my f of x, right? So I want to know when 1 million, is that enough zeros? equals 2 to the x. That's what I'm looking for. Does that make sense? Now, would I want to try to figure out how 1 million can become a base of 2? No. What would be the fastest way for me to solve this? The log. I would take the log of both sides. So I'm going to take the log of 1 million equals the log of 2 to the x. Okay, by taking the log, I'm setting my power what? Free. So my power is free. So it's no longer log 2 to the x, it is x log base 2. And what do I need to do to get x by itself? Divide it. So I'm going to divide both sides by the log of 2. So to figure out how many days it's going to take me, I'm going to need to find log of 1 million divided by log 2 or log base 2, 1 million.
But when you're writing under the fraction, is it log 2 or log base 2?
If I write it under the fraction, it's log 2.
Okay.
Yes. All right. So someone calculate. How long is it going to take me to become a millionaire? I heard someone.
Personally,
How much?
19.931. Well, you can round the 1, 2, and 2.
So almost how many days?
Almost.
Almost 20.
Oh my gosh, I don't know.
So if I have this magic coin for 20 days, I'm going to become a what? Million. Conclusion here is we discovered after we did our whole math, it was about 20 days, right? Ta-da, the answer was on the back all along. So it took about 20 days for the coin to be worth $1 million. Now it's asking us, how could we determine the number of days before the doubling coin has a value equal to any amount we choose? So what is it asking us to do? Find an equation. So if it wants us to find an equation where now we're given our output instead of our input, what type of equation are we looking for? What is it called mathematically when you're doing the opposite? The inverse. So it's asking us to find our inverse equation, okay? So we have talked about this. If we have f of x equals 2 to the x, what is its inverse? There we go. Say it again. Log base 2. The inverse that we have equals log base 2. Because the opposite of an exponential is a log. So now, what is it representing? What do we have here? So now we can write this in terms of us solving a problem, right? In terms of the problem, now x is our money, our dollar amount. And the output that we're going to get is our time. So does that make sense? Because we found the inverse, we now can input our money amount to find out how long it's going to take us in terms of time. Okay, so look here. Let's use this formula. So it says, if you were offered a single payment of $50,000 or a coin that doubles for a specific number of days, for what number of days would you opt for the doubling coin? Okay, so our input is now 50,000. Because we're given money as our input, are we using our original or our inverse? Our inverse. So we're going to be using inverse log base 2 of x. Okay. So now I'm going to find out the time for this problem is going to equal log base 2. And what is my money amount? 50,000. So when you look at example 3 on the front, didn't we have to take the log anyway? We had to solve it. But now we've already found a rule to follow. Instead of having to solve for log every time, we just plug in. And that's the purpose of a function, right? To make it easier and faster. All right, so log base 2, 50,000. What do we get, guys? About how many days will it take for us to get our, okay? Make sure you round correctly. Because if you round down, will I be at 50,000 or will be shortchanging myself? I'll be shortchanging myself. So we're gonna round
So
up.
what numbers are we trying to choose?
Repeat that question. I don't know how to answer it.
Like.
All right. So we have,
Oh, okay, got it.
so approximately it was like 15.9, right? So the thing is, if, well, 15.6
Oh, 9.
something, right? But if I'm at 15 days, will I have my 50,000? No. So we round up to 16 days. Okay. And again, if you are using the TI-84, how do you get log base 2 in the calculator? You either can write it as division, right? Log 50,000 divided by log 2, or alpha window. So if you don't want to write it as a division, you can do alpha, then the window button, and then you press 5, and you can put in the base, okay? So you either can write it as division, or you could do the preset format of alpha window 5, okay? All right, let's do it again. Here we go. So it says, if you were offered a single payment of 125,000 or a coin that doubles for a specific number of days, for what number of days should you opt for the doubling coin? Again, we're looking for time. So because we're looking for time, we're going to be using our base. Does that make sense?
Yeah, we do log 2.
So we have log base.
That's the double.
That's the doubling.
It's gonna be around.
That's like the factorial for multiplying by.
It's gonna be around 17 days.
Okay, so what did I get initially? What's my approximate value?
16.931.
We have about 16.9, which is about how many days? So on the 17th day, that's when my coin will be worth 125,000. Does that make sense?
Yeah.
Okay. All right. Now, how could I use a graph to do this? So if I was to use the graph that we created,
Go on the x-axis, the money is right.
yeah. So if we were to graph this, we make a whole new graph, and our graph function would be f of x equals log base 2 of x, right? Or if my calculator doesn't have log base, it will be log x divided by log 2, okay? The other thing that I could do is use my exponential graph. But on my exponential graph, instead of going to the x-axis, I would go to the y. So by that, I mean here, flipping over real quick, I'll go back. If I wanted to know, let's say 6 days, well, my x-axis represents my days, right? And my y-axis represents my money, my dollars, agreed? So if I wanted to know 6 days, I would go here. But if I wanted to know the money, or if I'm given the money, instead of starting on the x-axis, I would start on the y-axis, right? So if I wanted to know when I would have $10, let's see, 2, 4, 6, 8, 10. So let's say I want to know how many days would it take me to have $10? Well, I would go to 10, and it would take me almost a little over 3 days, right? Do we see that? So that's how you can use a graph you already have, is that instead of going to the x to find the y, you go to the y and find your x.
Oh, you smart.
Okay. So creating a whole new function, or using f of x equals 2 to the x, and you go to y to find x. And in this case, y is our money and x was our time. So now on part 5, we're summarizing everything we did. So on 5, what did we do? What was our exponential equation? So we started off with f of x equals 2 to the x. That was our exponential, right? From the exponential, we had to be given our what? But from the exponential, what was our given? What were we plugging in? In this case, x was our what? Our time. So with the exponential, x was our given time, right? 10 days, I would have how much? 12 days, I would have how much, right?
Ow.
Now our log, what did our log tell us?
How much money?
Our log told us, so f of x equals log base 2 of x. This time we're given our what? Our money, our amount. So depending on the question is going to determine which one of these functions I would use, right? So for example, if I asked you, calculate how much money I would have after 25 days, which one would you use? The first one, the exponential, right? Because I'm giving you a time to calculate, right? If I asked you calculate, how long will it take me to have $100,000? Then you would have to use the second one, the log one. Yes.
Could I hypothetically, just like go to calculator and just be like, 1 times 2, 2 times 2, 4, all the way.
I mean, if that's what your life told you to do in that moment, yes.
And I'm trying to laugh Friday, and I
Yeah.
got it faster than you. Ooh.
I went slow because I had to teach it.
I
Yeah.
You can do it internet.
I had to teach it, so to a certain degree, yeah. All right, so conclusion. It's asking if I wanted to make this in terms of dollars, and I'm solving for dollars, which one am I using? I'm going to use the second one. So instead of using x, it wants me to do what? So we would have f of d equals log base 2 of d.
That is weird.
Just so that I'm emphasizing what x represents in this one, right? X represents the what? The dollars. Okay? Telling you everything you need to know, right? You have Carmen here, and Carmen made an investment of $500 in a bank account that earns 2% interest every year. Okay? So notice when Carmen's equation was created, the 500 was her initial amount, right? Her growth rate is an increase, so therefore it was 100% plus 2%, right? That's 102%. So your 500 is your A, your 1.02 is your B. Do we see that? Okay. And then it wants to know, starting with A, to determine A of 5. Can you do that? Okay. Your hint for A is that this is a plug-in sitch, right? Plug in and explain what it means. So don't just give me the answer, but tell me this means blah, blah, blah. What is 5? What is your output? So what does your input mean? What does your output mean? Got it? All right. On part B, it wants to know, suppose no additional deposits or withdrawals are made to this account. Write an equation that can blah, 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 I can't talk, that you can use to determine the number of years it will take for the balance account to be 1,000. Then use your equation to approximate the number of years it will take for the balance to be $1,000. Okay, $1,000, is that your input or your output for your equation? It's our output. So you're taking, it's not changing anything. It's your output. So that means you're taking this and you're doing what with it? You're making it equal. It's your output. You're not inputting $1,000 in. It is your output. It's your result. It's what it equals. Okay. Remember that. Input is what I'm plugging in. This is an input, right? Yeah. If I'm inside of those parentheses, I'm inputting this in for my independent variable, right? This, it says, is 1,000. It's going to be my output. It's what I'm making. It's my money, right? So that's where we call that little math sense. The little math sense is mathematics mixed with common sense, okay? So we have 500 times 1.02 to the n, and my output is going to be 1,000. And that's what it's wanting you to calculate. So you're going to have to use log, okay? So step 1 for you to remember is you have to get it by itself. So step 1 for you to help solve is you're going to have to divide. Then step 2, you're going to use log. Got it? So those are your homework hits for part B. Cool? All right, keep going. Don't try to solve it right now. Let's keep going through all the things. All right, so next here, we have the number of bacteria colonies in a laboratory experiment can be modeled by an exponential function. F of t equals 10 times e to the 0.2, is it a 0.24? 0.24t, where f of t equals p, and p is the number of bacteria colonies. So my output means what? My output is the what?
The number of factor.
Thank you. My output is the number of bacteria colonies. That is my output. And therefore, T is my what? My number of days, and this is my input, okay? This is the beginning of the experiment. So it wants you to determine the values of f of 0, f of 3, f of 7, f of 10, and f of 14. What are all of these? These are all inputs. If I'm an input, I'm being input into the function, right, guys? Okay, so you're input and tell me what it means. On B, it says write a log function such that g of p equals t is the number of days. So it wants you to find the inverse, okay? It wants you to find the inverse of the function. So finding the inverse, same thing here. So if we have f of t equals 10 times e to the 0.24t, it's wanting you to find your whole shebang. And we want to solve for p. So what would I have to do first if any number? So if I had to solve for a number. So I want you to pretend that if f of t equal 10, what would I need to do to get it by itself? Well, we're going to give you your hints. Step 1 is to divide. Step 2 is you're going to take the natural log. And then step 3 is you're going to have to divide again. Okay? So in order to get to your variable by itself, we're going to do f of t. Yeah. We're going to divide. And why am I taking natural log instead of common log? Because it's e. Okay? Yes. Because it's e, we're going to take natural log.
Oh, yeah, not.
ln. Okay? On the back, it's a full problem. So starting from beginning to end, you're going to need to find your a, your b, write your equation, write the log that goes with the exponential, and work your way through. Okay? Those are your notes.
Oh.
Yeah.
Where's the assignment? Is it on Canvas?
So your assignment you got last Wednesday? That's due today? Yeah, you got it last Wednesday. Okay, remember A is your initial. And to calculate your B. Yes.
Weren't we solving it inside the class?
No, you're supposed to be finishing it for homework.
Oh.
Yeah.
I thought we were solving it inside the class.
You were finishing it.
Oh, okay.
Okay.
Yeah, to solve this one or this one.
No, 13 you didn't have to do, and then whatever we didn't finish was your homework.